By the end of this lesson, you should be able to determine the specific heat capacity of a liquid. Determine the specific heat capacity of a solid. Solve problems involving specific heat capacity. A lady takes a watermelon and sandwich from the fridge and leaves them outside. After some time, she touches the watermelon and sandwich. She feels the watermelon is cooler than the sandwich. Why does the watermelon stay cool for a longer time than the sandwich, even though both are taken from the same fridge? Both the sandwich and watermelon are initially at the same temperature. Why does the sandwich lose heat faster than the watermelon? This could be because the water in the melon, liquid, has a higher specific heat capacity than the sandwich, solid. It requires more heat to raise its temperature and takes a longer time to turn warm. Let's carry out simulation experiments to verify the statement. In this experiment, we are going to determine the specific heat capacity of a liquid, water. To weigh an empty beaker with a stirrer, drag and drop it on the weighing machine. With water until it is 3/4 full. Now, drag and drop it again on the weighing machine. The beaker is wrapped with a tissue and then placed on a polystyrene sheet to minimize the heat loss to the surrounding. Drag and drop a thermometer into the water and wait for it to attain thermal equilibrium with the water. Click on the Start button to switch on the heater. The rise in temperature of water equals to 75 degrees Celsius minus 25 degrees Celsius equals to 50 degrees Celsius. Assume that there is no heat loss to the surrounding and beaker, then the electrical energy supplied by the heater is Q equals P times T, which equals 36 times 420 equals 15,120 joules. Heat supplied by heater equals to heat absorbed by water. The specific heat capacity of water is 4,200 joules per kilogram per degree. This is a simulation experiment to determine the specific heat capacity of a solid, aluminium. Drag and drop the aluminium cylinder with 2 cavities on a weighing scale to weigh it. Mass of the aluminium cylinder is 974 grams. The electrical power of the heater is 36 watts. Drag and drop the electrical heater into the large cavity in the center of the cylinder. Drag and drop the thermometer in the small cavity of the aluminium cylinder. Add lubricating oil to both the cavities so that there is better thermal contact between the aluminium cylinder and the heater, and with the thermometer. Note the reading on the thermometer. Click on the Start button to start heating the aluminium cylinder with the heater. What is the temperature of aluminium cylinder after 5 minutes? What is the rise in temperature? The electrical energy supplied by the heater is 10,800 joules. Heat supplied is equal to heat absorbed. Assuming there is no heat loss, then heat supplied equals to heat absorbed. PT equals to mc theta. C equals to PT over m theta, equals to 10,800 over 0.974 times 12, equals to 924 joules per kilogram per degree Celsius. The specific heat capacity of aluminium is 924 joules per kilogram per degree Celsius. From the results of the two experiments, water is found to have a higher specific heat capacity than aluminium. In general, liquids have higher specific heat capacity. 200 grams of water with a temperature of 40 degrees Celsius is mixed with 800 grams of water with a temperature of 80 degrees Celsius. If there is no heat loss to the surroundings, what is the final temperature when the mixture of water achieves thermal equilibrium? Mass of water at 40 degrees Celsius, M1, equals 200 grams. Mass of water at 80 degrees Celsius, M2, equals 800 grams. Assuming no heat loss, heat absorbed by 200 grams of water is equal to heat released by 800 grams of water. Therefore, the final temperature when the mixtures of hot and cold water are in thermal equilibrium is 72 degrees Celsius.
This is a simulation experiment to measure the energy transfer between mixed substances using a calorimeter. A calorimeter is placed in a well-insulated container to prevent heat loss. Record the initial temperature of copper and water in the calorimeter. Initial temperature of copper rod equals 100 degrees Celsius. Initial temperature of water equals 23 degrees Celsius. Mass of the copper rod equals 400 grams. Mass of water in calorimeter equals 100 grams. Click on the Start button to transfer the copper rod into the water. The water is constantly stirred to make sure the heat is spread uniformly. The temperature of the water is recorded at 2-minute intervals. Click the Graph button to plot a graph of temperature versus time for the mixture. Based on the graph and the recorded values, answer the following. What happens in the temperature of the copper rod as time increases? What happens to the temperature of the water as time increases? The temperature of the water increases. What happens to the temperature of the copper rod? The temperature of copper decreases. How much did the temperature of the water change? How much did the temperature of the copper rod change? How much did the temperature of the water change? The temperature of water increased by 44 degrees Celsius in the same time interval. The temperature of the copper rod decreased by 33 degrees Celsius. Based on your observation, which substance has a greater specific heat capacity? Copper or water? Water has a greater specific heat capacity